Okay, please help me. Try to imagine yourselves in the middle of a grocery store, maybe Target, and you are there to buy cheese, milk, and a box of your favorite cereal. Okay, then you go you start with the cheese. You go, you see your regular cheese, your favorite one. Pick it up, and then you realize there are 24 pieces of that cheese. And maybe you are not very aware of the date that it is written in that cheese that warrants the end of the validity of that cheese, the shelf life of that cheese. But if you take a look, it is 1 week. You are 1 week from this date, and those 24 pieces will last for maybe 12 days because it sells 2 pieces per day in that particular store. So the cheese is going to expire in 7 days, and you have 12 days of inventory of that cheese. So what is going to happen? In day 8, all the rest of the cheese is going to be transformed in shrinkage. That is going to be a loss for the retailer. Now let's go to the milk. You go and there are a lot of different varieties of milk, non-fat, 2%, 3%, different brands, but there is not your favorite one. There is not the brand you like. Maybe you get angry with this store, and maybe you are going to change to substitute your milk. This is a decision that you take at this moment when you are in the store. Okay, and then now we go to the cereal. There are different boxes of cereals, and you can find your favorite brand of cereal. But behind, right close to this box of cereal, there is your second favorite. This second favorite is more expensive. Maybe the one you are looking for is $5, and the other one is $6. Each box, but it happens that it is 20% off of discount. This second favorite brand for you, and with this discount, it is going to be cheaper than the first choice. So it might change your mind, and you are going to pick your second favorite because it is cheaper and it is as well. As nice as the first selection. Well, maybe in this particular moment you are going to take 2 boxes of this cereal because it is 25% discounted. Okay, now let's transport ourselves to another situation. We are in the headquarters of this retailer, and what happens in these retailers headquarters is that the people that it is making decisions about how much merchandise you are going to send, they are going to send to each store. They don't see the client, the customer's behavior. They just see numbers. And we were talking about an example of just 3 items. But in the real life, the complexity of the retail grocery stores it's huge because normally a typical store stocks about 50,000 SKUs. the example that we are going to develop now, we are going to show you, is a chain that has 160 stores, very, very large stores. And imagine managing the stock, the inventories for these 160 stores for 50,000 SKUs, and all the situation that I was talking to you at the beginning of this talk is it takes place every day, every second, and the decision that it is, the decisions that are taken into the headquarters of this chain are going to impact directly the customer, and it is going to transform the perception that the customer has about the chain. If there is a lot of stock out, the merchandise that it is not in the shelf, maybe the consumer is not just going to be angry at that moment. Maybe it is going to be so angry that he stops visiting that store. And what happens with the first case that we were talking about, this shrinkage could be so large that the chain, the profitability of the chain could change from blue to red numbers. And this is very real situation, because in retail the margins are not so high. We are talking about the margins of the net profitability in the grocery industry is 3%, 4%. So errors in stocking merchandise in the stores could penalize heavily the profitability. Okay, the requirements. Can you go back, please? The requirements are very simple. Were very simple. Were to assure that the products remain available to the customers and keep margins under control and prices competitive. Very simple, but very complex at the same time. Two questions, very simple questions that summarize those requirements. How many items, how many units of product X I am going to sell in store Y next week? Which is the right price for product X to get a margin Y? Very simple questions. The mechanisms to get to those results could be very complex, but before we started using TreeNet, it was very, very painful to do that. We used to work with linear regressions, but many times we have outliers, we have a lot of missing values, and we used to have in our databases a lot of pollution because of events such as the World Cup, events of nature such as floods, and all those events are transforming outliers in databases that if we are talking about 50,000 SKUs for 160 stores, can be very complex. I must confess that before, when we run out of time to do the statistical work, we just took the average and we said, okay, let's repeat it. Let's do the average. Here, this is a plot of daily sales for one particular product. I think it is fresh onion. As you can see here, up again, can you go back? These are daily sales. Let's say that this product sells 100 kilos of fresh onions in this particular store. What happens when this product is in promotion? It can jump from 100 to 300 to 500. For more aggressive promotions, 1,000, 1,500, 2,500. And this is a tremendous volatility. What happens? What could happen if you prepare the store to sell in a very important promotion 2,500 kilos, and for some reason the competitor does the same thing, and you don't sell 2,500. Instead, you sell 1,500. Imagine how many days of fresh onion do you have in the inventory at the end of the promotion. You have enough to stop purchasing onions for several months. So for this case, the typical absolute error used to be 70 to 90%. Using, sorry, again, go back. Okay, this error was in the promotions, during promotions, but promotions were so important for this customer. More than 40% of the total revenues were made in promotions, which means 5 billion reais per year, which is $2.5 billion per year of revenues. Or if you have 70 to 90% of error in $2.5 billion per year of revenues, you have a problem. Okay. On the side of the price, the pricing side of this problem, we have as well an important error. Here, in this example, we can see a product that shows almost non-elasticity above 11 reais. When you sell this product at 11 or 15 reais, you are going to sell almost the same quantity. Elasticity starts here to show to be important when the prices are lower than 10.5 and grows exponentially here. Okay, but what happens? I studied this product, and 54% of sales of this product were made in this area, averaging 12.5 reais. So, what would happen if this product has been sold at 15? This 54% of the times that it was sold, if it had been sold at 15, unit sales would have remained the same. That's what it says, this analysis. But sales in revenues would have grown 13%, by 13%, and margin would have been grown by 40%. So there is a lot of money on the table that is left in the table by this retailer when it is not using this kind of intelligence. That is a lot of money as well, because we are talking about a chain that sells more than $5 billion per year in groceries. Okay, in this case, we are going to talk just about promotions, and we are just talking about the management of stocking the products. How much, the first part of the problem, how many units of product X am I going to sell in a store Y? That is the focus of this problem. We focus in 7,000 products that were promoted frequently, and we use these factors influencing sales. We decided to use these factors because we had data to represent those factors. I wish we could have more factors, but we didn't have the data. So we used the media. If it was advertising TV or advertising in the newspaper, radio, etc. The discount that it was made for that particular product, the calendar, if it was summer or if it was winter, if it was a weekday or weekend, holidays, the payday. By the way, payday is the holiday in Brazil. Prior promotions, how recent, how frequent this product was promoted, and some cross price effects. We analyzed and we decided, in the end, we decided not to pay much attention to this problem, because it was very complex to analyze it, to understand, to model the cross effects, and in the end, we didn't find a huge improvement in the models, and some assortment effects as well. These assortment effects. Do you remember in the example that I gave to you in the beginning with the cereal? The cereal. What happens with my favorite cereal if I am going to buy the cereal B that it is in promotion? What is going to happen with the other one? That is the assortment effect. Yes.
Question about cross-price effects, because that could work two ways. For example, you put a particular brand of hot dog on sale.
Yeah.
And a competitive brand sales are going to decrease, but there are complementary products like mustard that may increase. Are you talking about, both complementary and competitive types of effects?
Yeah, we tried to do that. It was so complex, and we decided not to do it in this time. We know that it is something interesting to do in further.
So you're talking about both?
Yes, both of them. Yeah, of course. Some other factors that I told you I wish to have, but we didn't, is weather, traffic, soccer matches, historical database, more data. There were a lot of data, but the further we went, the worse the database was. So we decided to keep 3 years of historical database. And now we are working with a customer that just they had a merge, two different chains, and one used to have very good database and the other one didn't. So now we are using a very small database, just 2 years, it's a challenge, but we are learning that our previous experience is working very well with as the base of new models. But we are going to talk more about that, which is very important for the solution. Okay. As well, we decided when we were building models, we decided to build models by groups, and we grouped all the commodities that we call the commodities: rice, beans, pasta, cooking oil. They seem to have a different pattern and the models were very similar, and we decided to work with all this list of groups: commodities, drugstores, items, drinks, bakery items, perishables, daily items, and miscellaneous. Particularly because it was important because when we made recommendations, how many products should we stock in one particular stock, we tune up the models, and it is very different. The factor that we used, it was very different if we were talking about perishables or if we were talking about rice or sugar, because these items can be stocked in the customer's house, but the rice and beans could be. So the tune-up is very, very different. I think we made a very good decision to group the different types of products. This chart shows a matrix that is nothing but an array of products here and stores. And the challenge was to say how many items, how many units of each product for each store should be stocked. And for a typical promotion of a flyer, we used to have 2,500 different products, just one flyer. And for 166 stores, we are talking about 450,000 different predictions. This kind of promotions could last 10 days. Now, if we have 450,000 predictions, times 10, we are talking about 4 million and more than 4 million predictions for just one event. As we had a lot of predictions to do, we decided to work rolling up the promotions. Instead of having a prediction for every day, what we did was to make a prediction for the whole promotion, and then we used a distribution to distribute for every day of the promotion. This is it is going to reduce the volatility, and but at the same time it is not going to be very important, because logistics in Brazil is not as flexible to have a one-day reaction. No, normally, reaction is 3 or 4 days. So when we were making the recommendations to stock stores, if we recommended to send 1,000 units of one particular product, we fractionate this 1,000 in 3 different deliveries. The first delivery should be 60%, so 600 products, 600 units went to the store. And then we had the first days of the real promotion to see what happened, if it was necessary to sell the other 400 units or not. So it was, we are going to see that the mixing our prediction with the real life solution to stock merchandise reduced in a very important quantity the error that I show you before. As I told you, there are in this database there are a lot of missing data, a lot. There are a lot of outliers. So if we had decided to clean up database, I think I would be there still trying to do that. It's very complicated to do that. So we opted for not data clean it, and we decided to use TreeNet. And then I fall in love with TreeNet. I don't know. I think it's something that fits so well to the retail business. And I have tried to use TreeNet for some other problems that we have in retail, such as programming the number of cashiers that should be open during the different days, different hours during the day. And it works very well. Because if we understand clearly what is going to happen with the sales of the products, we can use that information to predict how many customers and how many people we will need in the cash registers to manage all that quantity of products. Okay, I talk about that. I think it is. Everybody here knows about TreeNet, so I am not going to repeat all the qualities and why we choose it. But I am very, very, very happy to have done that. As I told you, we rolled up the promotions, and we made the recommendations based on these roll-up models. But at the same time, we work as well with the unrolled promotions, and we have as well the daily models. And perhaps in some occasions it is better to use one or the other. But as it was already done, we kept the two of them. Okay, what happened with the results was very impressive to me. Here in this chart, let's imagine that we sold 1,000 products, 1,000 units of cereal, and at the end, in the end of the promotion, we end up with 2,000. With 1,000 units. So we sold 1,000 during the whole promotion. In the end, we had in the inventory of the store 1,000. We are here. In this case, we are here. If we end up with 2,000, we are here. 3,000, 4,000, 5,000, 9,000. Okay? And you could ask, why, if you sold 1,000, how come you end up with 9,000? You must remember the first slide, the first chart, the first plot that we saw about the onion, the high volatility and the difference between sales, the 1,000 or 2,500. That's why we can end up with nine times what we predicted. So it was in the before we started using TreeNet. We used to in that industry we said that if in the end we end up with 2 times what we sold, maybe in this case 2,000 units of that product, we have a problematic inventory, because we have a lot of risk to transform this inventory in a shrinkage or to penalize heavily the financial situation, because we are carrying cost of a financial carrying cost of that inventory. So before, we used to have 45% of problematic of overstock, and after we reduced it to 15%. This is a 75% reduction of overstock, and on the other side here, we reduce as well 50% the stock out. Why did we reduce 60% the overstock? Because as I told you, we sent 60% of our prediction to the store, and with that 60% of the stock that we sent was enough to guarantee that we didn't run out of products, and that's why we could improve the other side as well. And that this is money in terms of sales, of revenues, and this is money in terms of financial cost of carrying the inventory. Yes?
I think you said before, right, that the baseline was just some kind of moving average forecast. Is that correct?
No, as well, we use a lot of regression, linear regression.
Yeah, so that's my question. In those two matrices, was stochastic gradient boosting being compared to the moving average, or was it being compared to more standard regression models?
To the whole thing, because we didn't separate that. Yeah. We just as I told you, if we had time, we run regressions. If we didn't have time, we just used the average. So the situation that we had before was the 45%, and the situation after TreeNet was 15%. Okay. And here, I told you that we made some tune-up in the models, and we use factors to increase or to decrease the recommendations. And by doing this, we increase accuracy almost continuously. We can see this in different kind of promotions. That we have 3 different kinds of promotions. In the 3 different kinds, we use different factors, and we were all the time improving the accuracy. We did all this in SQL Server, and this is very important. It was created a machine to automate modeling, because as you can imagine, to model to create models for 50,000 SKUs and 160 stores could be very, very painful. So it was created, this factory, to create models, and the models were they have this quality criteria. If the R square was not good, it was less than 1.10, it was not used, the model. Instead, it was used as substitute. And that was very, very important. And sometimes of course, these substitutes normally are related to products that are similar. Maybe it's the cereal, but a different brand. Or maybe it's the same brand, but different packaging, okay? All that production was automated as well. Nothing was supervised. Just controlled in the output was controlled. Okay. I am going to show you some interesting plots here. I think I am running out of time. So let's see here. We have 4 different products: detergent, condensate milk, fresh onion, rice, and rice. What happens here? We have the regular price is 1. Here we have 10% discount, and we can see an increase of the demand. And with 15%, we saw in this product 6 times. We sold 6 times more than the regular price. But here, in this product, with the 15% discount, which is here, we sold almost the same thing. Oh no, yeah, it is here, 15%. And onion, here we have it 15%, and it happens nothing. It must be a discount lower than 60% to start a different response. And we can sell here. Do you remember the 2,500 kilos that we sold of onion? Is when it is 70 or 80% reduced. Yeah, that's the explanation. But you know, when people in the marketing area is pricing products, they think here. They think they have a lot of meetings to decide that instead of 1, they are going to use 1.2, and it makes no difference. Yeah. This is another very interesting plot that shows the same 4 products. But here we can see the days, the number of days where the promotion starts to be less interesting for the client, for the customer. For this detergent in day 3, it is not interesting for the client. So a promotion of 10 days or 12 days makes no sense for this particular product. We have some other plots. Here we have the impact of the most recent discount. This is very easy to understand here. You see that if we repeat the promotion of condensate milk in day 10, there is no interest for the customer. In day 15, there is no interest. In day 25, it starts to become interesting again for the customer. And for rice, it's not interesting from the second day. Okay, we have as well seasonal patterns here. For this product, we see how this product is very seasonal product that it is sold in the end of the year, and then it keeps going until the second month of the year, more or less, because it's a summer related product. Okay, but regional effects. number of days before next holiday, a lot of information. Actually, the client never sees this information. We show it to you because it is important to understand a little bit what lies behind the models that were created. But for the customer, for the client, we just send the quantity of products, of units that must be sent to each store. It's very, very transparent. Okay, this is very, very interesting for the pricing part of the project, because can you go back here, please? This is the same price practiced by the competitor, and here we are 10% more expensive than the competitor's price, and we see that demand decreases here when we are more expensive. Even when we are at the same price, we sell less than the competitor, and when we are 10% cheaper, we start selling more than the competitor. And this information, it is going to be very useful for the second part of the project, which is the pricing. Well, my conclusion is that retailers with more than 30 stores have a very, very hard time to stock merchandise in the stores, and the management of these stocks and the management of the pricing makes a huge difference, because we are talking about very, very small profits in the talking about the ratio, and makes a huge difference to have some kind of tool doing this job that otherwise it is not very well done and needs a lot of human interaction. We demonstrated this with a massive retail stock chain that it is, as we talked in the beginning of this talk, that it is the second largest retailer in the world. And I think it is what we proved that there can be applied for any other retailer. Well, thank you very much.